Hey, what's up, guys? It's Wednesday, March 18th, I believe. I hope everybody's doing well. It's got plenty to eat and is spending much needed quality time with the family. Try to make the best of this situation. So let's recap a little bit on Monday. Monday, we talked about ferrous and non-ferrous metals and the difference between the two. So we know that ferrous metals contain iron. Non-ferrous metals do not contain iron. Ferrous metals are magnetic. Non-ferrous metals are not magnetic. Ferrous metal, good example, would be the mild steel that you guys use in lab. Non-ferrous metals are the type that you haven't used yet, but hopefully we'll be back in lab next year and you guys will be able to TIG weld some of these metals like stainless steel, Inconel, titanium, copper, nickel. Those are all non-ferrous materials. So we're going to check real quick with our objectives. We had the objective to define metallurgy terms. We're in the process of doing that. Once you guys have completed your vocab and taken your quiz, then we'll have completed the first objective. Compare and contrast ferrous and non-ferrous metals. We just did that in a short review. And from the responses that I got over the quiz that I sent out on Google Forms, it looks like you guys got a pretty good grasp on the difference between ferrous and non-ferrous metals. Going down to 3, describe 3 physical properties of metals. 4, describe 5 mechanical properties of metals. That's what we're going to talk about today. Physical properties of metals and mechanical properties of metals. So before we get started, I want to do a real quick review on the vocab list for this lesson of this unit. So our first term that we're going to come to recognize, and this is going to be in the physical properties of metals. Melting point, the temperature at which metal transforms from solid to a liquid. Thermal conductivity, the rate at which heat moves through the metal. Aluminum is a very good thermal conductor. Electrical conductivity, the rate at which electricity conducts through metal. Copper is a very good conductor of electricity. Tensile strength. You guys should all be familiar with this word. We use this as one of the numbers used in the electroclassification system. It tells us the tensile strength of that filler material. Tensile strength is the ability of metal to resist forces that attempt to pull it apart or stretch it. That is, simply if you had one piece of metal in your hands, the ability of that metal to withstand you trying to pull it apart. Compressive strength, it's just like it sounds. The metal's ability to resist forces that attempt to squeeze or crush it. A tin can doesn't have very good compressive strength. If I put my hand on both sides of a pop can, let's say aluminum pop can, and I squeeze it together or I try to compress it, I can collapse that can pretty easily. Now let's take an I-beam of the same size. The structure in the material and the physical properties, the physical properties of that metal has very good compressive strength, very highly resistant to compression. Hardness is the ability of material to resist being indented or punctured. So the harder the material is, let's use a ball-peen hammer for example. If I have a piece of metal, and let's just say it's regular mild steel, and I take a ball-peen hammer and I hit that piece of metal, more than likely, I'm going to see a ball-peen dent into that material. Now, if I've hardened that material and it's gone through, can't with mild steel, but a low or a high carbon steel, and it's gone through a heat treat process and it becomes hardened, that ball-peen hammer will likely just bounce right off the face of it and you'll never even see where it hit. So hardness is its ability to resist something hitting it or puncturing it. Ductility, the ability of metal to become permanently deformed without failure. That means it can't break. If it breaks, then that's not a good test of its ductility, or I guess to failure. If you're testing it to failure, once it breaks would be the end of that metal's ductility. So up to that point, aluminum is very ductile, right? I could take aluminum, I could bend it, and more than likely it's not going to snap in half. It's very ductile, and once I let go of that material, it's not going to bounce back. So it's ductile in the fact that it's permanently formed without breaking, snapping, or failing. Brittleness. Brittleness is the exact opposite of ductility. So ductility, I could take that and form that metal without it breaking. Brittleness says that when I try to start to form that metal, it snaps. It's brittle. Shear strength is the ability of material to withstand opposing forces. Bolts fastening two plates of metal together need to have good shear strength. Let's take construction as an example. So in the construction industry, columns and beams are bolted together. The bolts that make those connections have to have a high shear strength because you have loads from the floors above coming down on those bolts and causing that shear, that shearing effect, that we have to have bolts with high shear strength to be able to hold those buildings in place. Okay, and I'm sure you can think of a number of different things that has a bolted connection, and the shear strength on that bolt has to be high, or it'll snap that bolt in half and you'll lose that connection. Torsional strength, that's the ability of the material to withstand twisting forces, or torque. A truck drive shaft or axle needs to have good torsional strength. Okay, and let's think about a fabrication. So we know that a drive shaft, it's always spinning, so its torsional strength has to be good. Let's think about an overall fabrication that has to have good torsional strength, that's bending and twisting. So like a trailer frame. A trailer frame has to be able to bend and twist with the road in the conditions that it's going down. So it has to have high torsional strength. So we've got our objectives. And now let's start with physical properties of metals. So the physical properties of metals are characteristics observed when some form of energy changes the metal. Now that's important. And this is going to be on your quiz, on your Google Docs quiz. Physical properties of metal are when energy affects it. Okay? Examples of physical properties of metal. Magnetic. Is it magnetic? Magnetism is a physical property of metal. Having the tendency to react to magnetism, magnetic forces can be used to weld pieces together. The melting point. So we know that the melting point is the temperature at which the metal transforms from solid to liquid. If we take a torch and we heat up a piece of metal, and we start to see that go from its gray state to more of a blue, and then to a copper, and then to a purple, and then to a white, or an orange, and then into a white. Once we see that white, we know that those molecules are bouncing off all over the place as they're being heated inside the material, and it can only stay that way for so long. That melting point is the point at which that solid piece of metal becomes liquid and falls to the ground. That's the melting point. That is a physical characteristic of metal. Thermal conductivity, we've talked about this time and time again. So thermal conductivity is the ability that a metal has to be able to transfer that heat through the entire piece of metal. Mild steel, if we take a big chunk of mild steel, an inch thick and 2 by 2, 2 feet by 2 feet chunk of mild steel, and we lay it on a table, and we run a stringer bead down one edge of it. More than likely, we're going to be able to touch that other side of that mild steel plate and not even be able to feel that it's been welded on the other side of it. That's not true for aluminum. So aluminum is a very, very conductor of thermal activity. So when we weld one sheet or one side of that piece of aluminum, we'll likely be able to feel that heat transfer the entire sheet of aluminum to the other side. Okay, so its thermal conductivity is very high in comparison to mild steel. Electrical conductivity, it's the rate at which electricity conducts through metal. Copper is a very good conductor, so is aluminum. Those are the two main things used in like commercial wiring, copper and aluminum. Those are very thermally or electrically conductive. More so than, again, mild steel. Mild steel will carry a current enough for it to be able to complete the circuit for you to be able to weld, but it's not as good of an electrical conductor as copper or aluminum are. The physical properties of metals determine what applications suit different metals, and it helps identify various metals. These properties can also determine welding principles and practices. So again, physical properties are energies that affect the metal. Okay? That's very important. Mechanical properties refer to the characteristics of metal that display when a force, see the difference? Physical properties is energy. Mechanical properties is when a force is applied to the material. So examples of mechanical properties, tensile strength. Again, we talked about that. The metal's ability to withstand being pulled apart. Compressive strength. We talked about that one too. The metal's ability to resist compression. A pop can is not very compressive, or doesn't have a very high compressive strength. An I-beam does. It's able to take a lot of compression. Hardness is the ability for a metal to withstand puncture or indentation. Again, we use the example of a ball peen hammer hitting the side of a piece of metal that's been hardened. More than likely, you're not going to be able to see it. You're not going to be able to see a dent. A piece of material that hasn't been hardened, you're going to hit it with a ball peen hammer and you're going to see the dent of the ball peen. Another example of that is, say, on a knife blade. After you get done hardening, going through the hardening process of a knife blade, you can pretty much skate a file right across the top of it. The teeth won't dig into it. That's not true before it is heated and hardened and quenched. Before it's hardened, it's softer, and its mechanical property is not hard, and that file will dig into and scrape that material. Ductility, we talked about ductility. It's to be able to take that piece of aluminum or whatever that really ductile piece of material is and bend it to the point, let's say we bend like a weld coupon into a horseshoe. That ductility, that ability for it to be able to bend into that horseshoe shape and stay there when I let it go and not break or fail, is that ductility strength of that piece of material. Brittleness, it's the exact opposite of ductility. So when I start to bend that thing, it snaps, it's brittle. Shear strength, again, we used bolts as an example before in like a construction project. The shear strength of the bolts need to be really high or it'll shear in half. The bolt will, and everything will come apart. The difference between, let's use the big shear in the back of our lab. Okay, when we shear cold rolled steel, or mild steel rather, when we shear mild steel, it's a little bit more difficult, not much, but a little bit more difficult for that shear to break through and to shear that piece of material. Whereas aluminum has a lot less shear strength, and it cuts through that aluminum piece a lot better than it does in mild steel. The ability of metals to resist or withstand these mechanical properties directly applies in determining the use of these metals. For an example, an axle shaft needs to withstand twisting forces, so high torsional strength steel should be used. Again, the reason you need to know these are so that you're able to make an educated decision on what type of material to use for different applications. You have to be able to understand physical properties of metal, and you have to be able to understand the mechanical properties of metal. So I think that pretty much concludes the difference between physical properties and mechanical properties. I'll be sending out a Google Forms quiz on this lesson right after this. I appreciate your feedback from the first quiz. That needs to be completed by Friday. This will be our last video for this week. I'll be touching base with you guys over the weekend. Make sure you're checking those emails on a regular basis. My next video will be Monday. We'll be carrying on with this same unit. And then Thursday, we look to have a vocab quiz. So be practicing your Quizlet, and you guys stay safe, and you know how to get a hold of me if you need to. Have a great rest of the day.